Okay, are you able to see my screen?
Yes, madam.
Yes,
Yes,
ma'am.
okay. Now, yesterday, what we did about the simple regression. That means we are having two types of regression. One is your simple regression and one is your multiple regression. And we did that the variable that is influenced, that is known as dependent variable, and the other variable is known as the independent variables. So simple regression means your bivariate regression, and multiple regression means when there are more than two variables. One will be your dependent and more than one will be your independent. And we also did that some of the variables which we are not able to include in our model that will sit in our error term. So what we have to do, our model will be a good fit when there will be a minimum error. So what we have to do, we have to minimize the error. We have to completely convert the error term into zero. We have to show that we have given our 100%. Whenever I have given you so many examples, if you are giving your exam, so what you will do whenever we are doing the exams, so our marks are depending on my performance, right? So marks is my dependent variable and my performance is my independent variable. So whenever a child performs the exams, he always says that I have done my best. So that means in that case, he has avoided all the errors. He don't want to do any error. That's why he is saying that I have done my best over there. So in our case also, in any regression, whatever we are doing in time series, each and everything is regression. Maybe I'll be doing your ARIMA model. Maybe I'll be doing your Arch and Gauge. Maybe I'm doing your co-integration. Maybe we are doing the panel data. Everything is related to regression. So if regression is clear, that means most of your queries will be solved. So what we have learned in regression that we have to create such a model that whatever variables we are taking, that should explain the dependent variable. We should not include any such variable which is not explaining the dependent variable. Second, what we have learned that error should be minimum. There are different names for the error. As we are moving further, we will learn the different names of the errors. So error should be minimized. That's why we always say that if you have, see over this, see, my assumption is that there is zero mean of error term. Zero mean of error term means if we are going to add all the error terms and divide it by a number of error terms, it should come out to be zero or near about to be zero. Or indirectly, I can say that zero means a person is getting 0 marks. So zero error should be there. So that's why we are saying error should be zero. If error is zero, it means whatever variables we are taking that they are explaining the 100% results. Now, after that, you have seen that my next assumption is that there is no or low correlation between your independent variables, or we can even name it as multicollinearity. So why we are saying that? Because whatever independent variables we are taking, there should not be any relationship among themselves. Suppose I say that, let's say marks only, right? I want to, I am a student and my marks are depending on my performance. And one of the variable is performance. One of the variable is the studying and the studies, the number of hours I am doing. And one of the variable is my ability, my intelligence. So that means if I say that, or one of the variable, I can say that qualification of my parents. If I'm saying the qualification of my parents or intelligence of my parents and intelligence of myself or ability to do the work myself. So you will see that normally you will observe that the intelligence comes from the parents, and mainly uh, if you will study the biology deeply, you will know that The mind is being developed by the mind of a mother. If mother is intelligent, it's, you can say, 99% sure that the child will be intelligent. So if I take the two variables, let's say my intelligence and my mom intelligence, so they will be related to each other. They will be having a correlation among themselves. And whenever we are explaining the dependent variable, what we have to do? We have to see that which independent variable is contributing how much part in explaining the dependent variable. Now, in this case, if I am intelligent, my mom is intelligent. So there will be some common part in both of them. So I cannot say that which variable is explaining my marks. As I gave you yesterday also the example of heart attack. If a person is in heart attack and person is a smoker and person is also having a high blood pressure, so how can I judge that heart attack is due to smoking or due to high blood pressure? Because if I see that, I have to see whether the heart attack is by smoking, so I have to keep your heart attack to be constant. But I cannot keep the heart attack to be constant, because if I am a smoker, it's a, I'm saying not heart attack, it's a BP. That if I have to see that how much smoking is contributing towards the heart attack, so it means I have to keep the BP to be constant. But in real scenario, I cannot keep BP to be constant. If I am a smoker, it's sure that my BP will increase. So that means in this case, it's not possible to keep the other variable constant. So I'm not able to explain the reason of heart attack. And I'm not able to explain whether the heart attack is due to high BP or due to smoking. So that means the results that I am getting will be biased. So what I have to do, I have to remove any of the one variable. That means first of all, I'll check that whether heart attack is due to smoking. So my dependent variable will be heart attack and independent will be smoking. And second model I will create for your dependent heart attack and your independent to be blood pressure, high blood pressure. So then I will see that which independent variable is contributing in explaining that why the person is having heart attack. Or if there are more than these variables, so remove one by one. If you are finding that there is a correlation among three variables, make three models and then compare that which model is a good fit. So multicollinearity should not be there, otherwise your results will be biased. Similarly, we have done this thing, no autocorrelation between the errors. So now we are saying error term should be 0, mean should be 0. So that means if they are having the relationship among themselves. So you can see that if two error terms are autocorrelated, then there will be the correlation among the error terms. If I am saying there should not be correlation among the independent variables, so whatever variables are hidden in the error terms, there should not be any relationship among themselves also. What are errors? Errors are those terms which are not visible on the independent variables which are hidden in the error term. So there are certain variables sitting in the error term. There should not be autocorrelation. That means one variable should not be related with its immediate lag or 2 days back lag or 2 months back lag. It should not be related with itself. If it is related with itself, so what we have to do? We have to take that variable out. And if we are getting the answer that the correlation is there, autocorrelation is there. So we have to see why we are getting the autocorrelation. We have to find out that unobserved variable. What are the reason why my model is not a good? We also did that residuals should be having the homoscedasticity. Now, what do you mean by word homo? Homo means similar and scadicity means difference. So homoscedasticity says that there should be similar difference throughout. That means your residuals, all those variables which are sitting in the error term, which we have not included, they are equally spread. It should not be that one variable is increasing and other variable is not increasing. So they should be equally spread. And opposite of homoscedasticity is heteroscedasticity. Hetero means different and scedasticity means your variability. So that means all the residuals vary differently. Some are having a small distance and some are having a big distance. That means they are not varying equally. So if this is a case, then again our model is not a good fit. So that means some biasness is there. So again, homoscedasticity should be there, heteroscedasticity should not be there. And if homoscedasticity is there, that means my model is a good fit. That means all the variables that I have included in the independent variables, they are explaining my dependent variable in a blue manner. Residuals are normally distributed. So whatever residuals are, we are saying they are normally distributed because the data always works on the normal data. So if we are checking what we are doing by ADF test, we test all the variables which we can observe because they are observable. So we can check by ADF.test whether my data is normal or not. If it is not normal, we just try to convert it. And the residuals means those variables which are not observed, which we have not included in the independent variable. So that means if we are saying your independent variables should be normal, so all those variables which we have not taken, which are being hidden in the error term, they should also be normally distributed. So that's why we say that residuals should be normally distributed. And the coefficient of parameters, maybe your independent and dependent variable, should be having a linear relationship. So these are the certain assumptions that has to be fulfilled in each and every regression equation. Each and every means if I'm doing ARIMA also, same equation, same assumptions. If you are doing arch and gauge, same assumptions. If you are doing your co-integration, same assumptions. If I am using your impulse response function, same assumptions. If I am using your panel data, same assumptions. Your assumptions are same because everything is regression, everything. Now, you just tell me whether all the regressions are only linear or there can be curvilinear. And if curvilinear is there, then what will be the condition of curvilinear? Yes, what is curvilinear? If I am saying linear means this line. Well, anyway, the line should be straight. And if I am saying the curvilinear, your line should be some way. For example, I can say this part, this way. Some curve should be there, or it can be this way. That means linear is there, but some curvilinear. It can be this way also. Straight line is not there, but curves are there. Can I get this situation? Can I get this type of situation anyway? Yes? Anyone? Yes, can anyone explain it? Whether I can get only this type of regression, a straight line, or I can get a curvilinear line also? And when I'm going to use this type of regression?
Ma'am, there can be a curvilinear, like for example, if the linear like impact is more than double or of a particular variable,
Can
like
you give me an
inflation,
inflation?
like
So
inflation has
if
multiple
inflation
impacts on
if inflation is double, I can write 2x. So y is equals to a plus 2x. 2x means inflation. The impact of inflation is twice on the variable y. So it won't become your curvilinear. Any case. Yes, any case. Yes. No one. See, but we have learned in maths. Math says the linear equation says where the exponents are 1. That means y ki power 1, your x ki power 1. That is known as your linear equation. And we have also done in our regression x on y term or y on x term. So that is a linear equation. And if I am going to put any values in it, if I am going to put x to be 1, then my y will be, suppose a and b are 1 and 0, so it will comes to be 1 only. So it will be a straight line. If you are going to plot it on your number line or your this graph, it will comes out to be straight line. Any points if you are going to put it. But let's say I'll just take a small example of Leffer's curve. Do you have any idea what is Leffer's curve? This is an economics terms. What is Leffer's curve? Anyone knows it? It's an economics term. No one? Okay, let me give you an example. I did one research on the direct tax and Leffer's curve.
Yes,
We
ma'am.
all are
It
paid.
shows the. Hello, ma'am. Leffer curve shows the relationship between tax rate and tax revenue.
Yes. So can you explain it? What the Leffer's curve is showing?
Ma'am, it is an inverted U type of curve.
Yes, it is an inverted. I have made the inverted U type of curve, but how can you explain it with the help of your direct tax and revenue? Tax rate and revenue. It's related to tax rate and revenue. Okay, let me
Ma'am,
explain it to you. Yes.
No, ma'am. I can explain. You please explain, ma'am.
Okay, now what happens when we were in 1950s, we have a tax rate which is very much high. If you will observe the previous data, you will see that there is a very much high tax rate, and around 1990s, the tax rate is reduced to 30% maximum tax slab that we have discussed. That right now our maximum tax slab is also 30%. So in 1993, it reduces to 30% below. Before that, it is more than 30%. And there was a time when even the tax rate was 80 to 90% in India. So now suppose if I am saying a government puts zero tax rate, over here is zero. If zero tax rate is there, that means government is not having any revenue. If I don't have to pay tax, that means revenue for the government will be zero. I'm not paying any tax. Okay, now what happens? Government says that I need revenue to run the country. So government put 10% taxes over there. So that means if 10% taxes, these are the tax rates and this is your revenue. That this vertical line is your revenue and your horizontal line is your tax rate. So if 10% tax rate, I put it over here. So if 10% tax rate is there, revenue increases to the government. 20% tax rate, revenue increases. 40% tax rate, revenue increases. But suppose this is your 50% tax rate, and if 50% after 50%, what happens to the government? If government is increasing the 60% tax rate, revenue decreases. Similarly, if the government says that now I'll put 100% tax rate, this is my 100%. So that means at that case also government will having a zero revenue. Why? If I am giving 100% whatever I am earning to the government, so why should I earn? I'll also become lazy. I'll say that if whatever I am earning, I have to pay to the government. So there is no use of funding. It's better don't earn. So that means whether government charges 0% tax or whether government charges 100% tax, government will have zero revenue. So in that case, what is happening? There is a maximum tax rate that the government can charge from us, where government can earn the maximum revenue. Beyond that, if government is going to charge any taxes, the curve will start moving downwards. So this is known as Leffer's curve. Now what happened? Now if you will see, if I'll draw a straight line over here, let's say I'll draw a simple straight line. This is my simple straight line over here. Now on this simple straight line, that let's say this is your government revenue, and government is earning 10,000. So government is earning 10,000 when the government is tax rate is, let's say, 20%, and over here let's say the tax rate is 80%. So that means there will be two tax rate where the government is earning the revenue. So it becomes your square. So whenever you are having the conditions like this, curve are moving, that is known as your curvy linear regression. Let me give you one more example over here. Let's say we are comparing the experience, whatever experience you are having, and with your salary. I am saying as the experience increases, your salary increases. Is this true or not? As the experience increases, your salary increases. Is this
Yes,
fine?
ma'am.
No, it's not fine. Now, if I compare the experience and salary, that won't come true. I am having the experience. I am in teaching from last 20 years. That means 20 years experience I am having. So that means my salary should be more than those persons who are having only 1 or 2 year experience, right? This should be the scenario, isn't it?
Yes, ma'am.
But that's not true. If I compare my salary with some right now in this situation, the persons who are right now graduating, even the 30 years child is earning more than my salary. Maybe he's not having that much experience that I am having, but still he is earning more than what I am earning. You can go in any situation. Even a 60-year-old person is earning same as the 30 to 40 years old person is earning. So that means as the experience increases, it's not compulsory that the salary will also increase. Thus, if this is my salary, if I am earning 10,000, I am having 20 years of experience. The same salary is earned by 10 year, the person who is having a 10 years experience also. So that means on the same salary, two people are there with different experience. So in this, the curve will be there. So that will be known as curvy linear. That means same revenue with two different situations. So you will observe that whenever you are comparing the experience and the salary, you won't be making a linear equation. Your one of the variable will be salary square. I'll be discussing this in panel data also, that in that case, we will not take simple salary. We will take salary square, wages square. So square comes into the equation. So whenever the square comes into the equation, it becomes the quadratic equation. And whenever the quadratic equations are there, quadratic equations are always the non-linear equation. It's not that 100% over here it will be curved. It can be a slightly curve and then curve, or slightly curve only. Some curvy linear part will be there. So whenever such situations are there, we have to keep it in mind that whether we have to take one of the variable to be salary, or I have to take the variable to be salary square. So if you are taking salary square, it's understood that you are using the curvy linear. Everything is same, assumptions are same. Nothing is different. The only thing, the variable that you are taking. If you are taking simple salary, it becomes a linear equation. If you are taking salary square or anything, a square part, it becomes curvilinear. Even we can take cube also. We have learned in maths, the equation can hold cube also. If cube is there, then it's a one turn and one more turn will be there in your line, in your regression. So it depends on the situation. We have to understand the model that we are going to create. Okay, now let's move with our assumptions, how we are going to solve these assumptions. Are you able to see my R?
Yes, ma'am.
Yes, ma'am.
Okay, import the data set. Now attach it. And library the packages. T-series and library LM test. Just library these two packages. Now we have to create a model. So we are creating model. We are giving the name model equals to LM. And first of all, any variable you can take. I'm taking FDI to be your dependent variable. Exports plus imports plus your inflation rate. Done till here? Have you created a model? Wait a minute. Okay, everyone has created the model.
Yes, ma'am.
Now, what we have to do, we have seen that our model is there. Now we have done that. I have to see whether my all these variables are explaining the dependent variable or not. So you will write summary and your model. And whenever you will see, you will create the model. Now this type of sign will be there in your R. So either you can click over here or just write model and the summary is there. You will get all the details that your intercept is constant is this, is this, imports and inflation rate. These are the estimates. And this is your p-value. Since p-value is not less than 0.05. So whatever estimates I have taken that are not explaining the FDI. That if I want to see why the FDI is increasing or decreasing, what are the various factors through which FDI is being impacted. So I have taken these three variables and these three variables are not having any impact on FDI. So I have to take some other variable. Okay, just a minute. Let me give the entry. Okay, now that means you are getting this much. Now we are going with the first relationship. That means, or you can say first assumption, there should be a linear relationship between variables. Let's write it over here. We have done yesterday also, there should be a linear relationship between the variables. So let's find out how we are going to find out whether there is a linear relationship among the variables or not. So we have also done this part that mostly my all the assumptions are related to your error term. Why? Because I have to minimize the error term. Whatever the variable independent variables are there, the same thing should be there with the terms which are not observable, which are hidden in your error term. So linear relationship between variables, for that we have to first of all create the residuals. So for that, store all the values of the residuals in one vector. So let me name it residuals. I'm giving residuals of model is equals to your residuals and model. So now you will see the vector residuals underscore model, because I have given the name residuals underscore model, is created over here. So these are your residuals. So now let us check the first thing. So that is your plot. I'm going to make a plot and for what? Residuals. Residuals underscore model. Now, are you able to see this graph? Now, can you observe there is some straight line, some pattern is there or not? There is forming some pattern, no straight line is there. You will see the variables are here also, some residuals are here, some here, some here, and even the variables, one of the residual is over here. So it's not a straight line. If you are getting a straight line, then only there must be a linear relationship. If you are not getting a straight line, linear relationship is not there. So that means my first assumption is violated. Now, write the another way, how we are going to do, how we are going to see the plot. This is one of the way. Directly make the plot of the residuals, or another way is make the plot of the model. Just write model, comma 1. Now see over here, it's always with the residuals only. There are two ways to representing whether there is a linear relationship or not. Either make a plot, first of all create residuals and make a plot of residuals, or write the command plot model comma 1. Now you will see there is not a straight line. Are you able to see any straight line? No, it's not a straight line. Straight line is not there. And second thing, what you will observe that if we are passing a line from 0, all the things, all the variables are not falling on 0. This red line is not passing through 0. It's near about 0. Near about 0, but not passing to 0. That means 0 mean is exact 0 mean is not there. Near about 0 mean is there. And if such situation is there, we can say that 0 mean is there. That means it's not that 100% you should get 0. It's near about 0. If you are getting near about 0, so I can say that residuals are having 0 mean and one of my assumption is fulfilled. Got it? Any doubt over here? No doubt?
Ma'am,
Yes.
ma'am, can you explain the residuals again? This
See,
model, ma'am, this model.
Residuals are what? Residuals are remaining part of the variables which we have already taken in our model. Right? If I'm saying that heart attack is due to your smoking or due to your age, I have taken these two variables. So, and there must be some variables. Let's say I talk about the hereditary part. That's a family history that we are having the heart attacks. And that family history is sitting in your error term. So whenever I'm creating a model that heart attack is only due to my age or due to my smoking. So the family history that is which is sitting in the error term, which I have not included in my model, that answer should be 0. That means heart attack should not be due to the family history. So residuals means all those variables which we have not included in our model. Their mean should be 0. Error should be 0. So for that, what we have to do, we have created this model. This is my model, and we have to now create the residuals. What is residuals? The leftover. So if I have extracted whatever information I am having, this is my data. From this, I have created the model, but still some information will be there which is left behind, which I have not taken. There must be some variables which I have not taken. So I have to observe those variables which are hidden in that. So model this software has done, it has created the variable residuals. But you can see I cannot observe these residuals. These are mere figures that it has created. But it is not observable. I'm not aware that which variable this residuals has taken. So whenever we are creating the residuals, it should follow all our assumptions. So one assumption is that there should be a linear relationship. Second, your residuals should be 0. The mean should be 0. Now over here I am saying mean is near about 0. We can say it's 0. So whatever left part is there, it is not explaining my dependent variable. If it is not explaining, then only this residual should be 0. If it is 0, that means it's not explaining. Now, next is we have done the first thing we have done, there is a linear relationship. We didn't find there is a linear relationship. There is a curvy linear relationship. Second, the mean should be 0. Second part kya? Okay, second, let's say we don't take residuals to be itne. Residuals mean is 0. Residuals mean is 0. So now what we observe with this diagram, mean is near about 0. Either you can make the diagram with the help of same command, plot model 1, or you can directly write mean of your residuals. And the name of the residual is residuals underscore mean. Now, if you will see this value, residuals underscore mean, the value comes out to be minus 3.552714E minus 15. Minus 15 means decimals are to be shifted towards left. So your answer will be 0.014 times 0, then 35714. So, okay, let me give you the complete. I told you every time, just you can just write options. Sky pen equals to 999. Now, if I'm going to write the same command, mean, now you will see this is your exact value. The mean is minus 0.00000003552717. So it's near about 0. The diagram is also saying that my mean is near about 0. So I can say my mean is 0 and this assumption is fulfilled. Okay, let's move to our third assumption. Third assumption is saying residuals should be normally distributed. Residuals should be normally distributed. So one way how I can do my residuals are normally distributed, if I'm going to say my H0 is your residuals are normally distributed and your H1 is residuals are not normally distributed. So now whenever I'll be going with the test, if my test value P value is less than 0.05, I'll go with H1. And if my P value is more than 0.05, I'll go with H0. Or ultimately, I can say if value is less than 0.05, my data is not normally distributed. My residuals are not normally distributed. And if your P value is more than 0.05, your residuals are normally distributed. So one of the way to make the residuals, whether we have to see whether my residuals are normally distributed or not, we will make QQ plot, quartile plot. So if I'm going to make a QQ plot and if I'm going to see that all the residuals are lying on a straight line of QQ plot, then I can say my data is, my residuals are normally distributed. And if they are diverting from the line, then I can say that my residuals are not normally distributed. So let's make it over here. So command is QQ norm. Why? QQ is your quantile and norm means whether they are normally distributed or not. So with the combination of QQ normality, we make the abbreviation over here QQ norm and then your I've given residuals underscore model. Now observe this diagram. Now is there a straight line in this diagram? Is all the residuals are on the straight line? These are your residuals. Are they on the straight line? If I draw a
No, ma'am.
straight line over here, so that means my residuals are not normally distributed. Now let's see how to make a straight line and then check whether your residuals are normally distributed or not. So plot model, comma 2. Now see over here, your line is there. Are you able to see this line? This dotted line? Are you able to see this dotted line? So now see all the variables till here, they are on the dotted line, but above that, all the variables move upward. That means they are not on the straight line. So I can say that my data is not normally distributed. Or another way is just write plot and write model and press enter 3 times. 1, 2, 1, 2, 3. So you will get the same diagram. Got it? Any doubt? Now, these are the way of making a diagram. By way of plotting, I can observe that my data is not normally distributed. Now, let's come to the test. So we have learned by one way by QQ plot. Now we will go with some tests. So first test will be your Shapiro-Wilk test. Now, when we are going to use this Shapiro-Wilk test? When we are going to use this Shapiro-Wilk test? That means whenever your observations are less than 50. If your observations are less than 50, you will use this test, Shapiro-Wilk test. So now let's do it. Now, just write the command for Shapiro-Wilk test. Shapiro Shapiro.test and then your residuals. Residuals underscore model. Now, you can observe that your p-value is less than 0.05. If p-value is less than 0.05, I will go with alternative hypothesis, which is saying residuals are not normally distributed. And this diagram is also explaining the same thing. This diagram is also explaining the same thing, that my residuals are not normally distributed. Got this point? Now, if your variables are more than 50, then we are going to use Komlogrov-Simrov test. Okay, now let's go with Komlogrov-Simrov test. Now, simple command ks.test. All the commands are very simple with the abbreviations only. Residuals underscore model and then enter. Now again, order Y is missing. There is no default. I think something is missing over here. Okay, yes. Now command will be ks.test. I have not given the command residual underscore model, and I have to give the command p norm, whether it's a normality or not. Now you can see over here again, p-value is less than 0.05. Again, it's saying that residuals are not normally distributed. And one of the common
Ma'am,
tests.
this KS test is for above the 50 observation.
Above 50 observations.
Okay, ma'am.
And the next is the commonly used is Jarque-Bera test. Normally in your time series, you will see the Jarque-Bera test, which is used to explain whether your data is normally distributed or not. So for that, your command is Jarque-Bera test. And then residuals underscore model. Again, you will see that your p-value is less than 0.05. So again, it's saying that your residuals are not normally distributed. So these are the different tests by which you can say that your data is whether your data or whether your residuals are normally distributed or not. Now, next assumption, your fourth assumption. Now, fourth assumption says that error term should not be correlated, or you can say there should not be autocorrelation. Now, if I'm saying there should not be autocorrelation, that means your error term, or let's say like this, your ET. Instead of error term, I am using ET. ET should not be correlated with ET minus 1 or ET minus 2. Error term
Ma'am?
should not be, yes.
Ma'am, Jarque-Bera test is not coming.
Jarque-Bera test is not coming. Why? This is Jarque.Bera.test.
It says I could not find the function.
Have you this library, the T-series package or not?
Yes, ma'am.
You have library, the T-series package, then it should come over there. It's see over here, Jarque.Bera.test, and in bracket you will observe the package name is there. So if you have downloaded this package in your, or you have library, if you have downloaded the package, that means these package is already installed in R, but you have not library, it will not show. I told you each and every time you are opening the R, you have to give the instruction to R that these are the books of R. That please open this book, I have to read this book. So Jarque-Bera test is a test which is the part of T-series package. So if
Okay, ma'am.
T-series
Okay, ma'am. Already
package should
given
be
the result.
library. Okay. And one thing more, you don't have to write whatever the commands you have given already. What you can use, there is a upward and downward arrow in your system. So if you are using the upward arrow, see, I am using the upward arrow. If I press 1, the last command will be there. If I press this 2 times, the previous command, the second last command will be there. If I press 3rd time, third last command will be there. So what, you don't have to write the complete commands again and again, just go with these arrows. So each and every time you are doing, go with arrows. For example, if I have to check, there are 10 variables, I have to check the ADF test. So it's not that every time I'm going to write ADF, just press the arrow and then enter. Or another way is you can go to the history over here and whatever test you are applying, suppose last is my Jarque-Bera test, just press it and tell it to send it to console. So it will already give you the test and then press enter. You will get the results. I have used Jarque-Bera test twice. It will show in the history that I have used it twice. Now, there should not be autocorrelation. There should not be autocorrelation means your error term should not be related with its past. Now, whenever I am saying past means your lag values. So it can happen that I give you the example for advertisement. If the sale of today's date can be impacted by the advertisement, I have not included the advertisement in my variables, independent variables. So it will happen that today's advertisement is affected by previous day advertisement, or today's sale is affected by today's advertisement also, and by the advertisement which I gave in the last month also. If right now it's a September, so September sale is impacted by the advertisement given in the month of September. It's obvious, but it can also be impacted by the advertisement that I gave in the month of August. So advertisement is sitting in my error term. September advertisement is known as ET. August advertisement is known as ET minus 1. And July advertisement is known as ET minus 2. Your June advertisement will be known as ET minus 3. Because that is the advertisement that I gave 3 months back. So 3 lag is there. So ET minus 3. So now what happens? It can happen that the advertisement that I gave in the month of August is having the impact in September. That can happen. Or even it can happen, the advertisement that I gave in July, that is having an impact in today's date. So if the impact of July advertisement is there, so I will say ET minus 2 is related with ET term in today's date term. Or if August advertisement is having any impact in today's sale, so I'll say that ET minus 1 is having a relation with ET. So if ET and ET minus 1 are having relation, so I'll say it will be a autocorrelation of degree 1, or it is a autocorrelation of first order. And if ET minus 2 is having any relation with ET, that means today's sale is impacted by today's advertisement plus advertisement of 2 months back. So that means I will say that there is an autocorrelation of more than degree 1. Got this point? How we are going to say whether it's a degree 1 or degree 2 autocorrelation? So what we are doing, we are just calculating whether autocorrelation is of degree 1 or more than degree 1. We are not saying 2, 3, 4. Either 1 or more than 1. Got it? Any doubt till here? Any doubt?
No, madam. No, madam.
If it is a degree, if degree 1, that means if ET and ET minus 1 are related, so I can say if ET and ET minus 1 are related, then we are going to use Durbin-Watson test. And if ET and ET minus 2 or ET minus 3 and so on are related, then we are going to use Bush-Pagan test. Bush-Godfrey test. So you have to remember these two things, that when we are going to use Durbin-Watson test and when we are going to use Bush-Godfrey test. So first of all, let's go with the Bush-Pagan test. So again, Bush-Pagan, the short Durbin-Watson test short form is DW test. So DW test and your model. So now see, the p-value is your 0.004016. So H0, if I'm going to write over here, H0 says that, what should be your H0? There is autocorrelation or there is no autocorrelation? Yes,
No
what should be your H?
autocorrelation.
No
No
autocorrelation. And if H1 is there, so this means there is autocorrelation. And you will see p-value is less than 0.05. So we will go with H1. So there is autocorrelation. Now, how to solve it? If there is autocorrelation, if you are able to observe the variables, I know that advertisement. So what I'll do, advertisement of the month of September and advertisement for the month of August. These are two advertisements that are sitting in the error term. I will take one out. That means I'll make one of the advertisement as an independent variable. Then my model will become a good fit. So now I'll say one is my independent and one is sitting in the error term. So if I take out one, so error term will become, there will be no autocorrelation among the error term because I have taken out one. So if there are no two terms, so no relation is there. Now, next is your Bruch-Godfrey test. So again, for the Bruch-Godfrey test also, what should be the command? Till now, you are able to calculate what should be the command? Bruch-Godfrey? BG. Abbreviation, always use the abbreviation. Bruch-Godfrey, B for Bruch and Godfrey for G, and test. Bruch-Godfrey test. And again, your model, comma, order 3. You can take anything because we have already done that Bruch-Godfrey test is used when there is more than degree 1. I can just assume that there can be degree 2 also. That means September advertisement and July advertisement are related. I'll write order 2. If September advertisement is related to your June advertisement 3 months back, I'll write order 3. So it's up to you what you are going to find, and this will be your answer. Now over here, if I'm taking order 3, that means if I am comparing that whether today's advertisement is related with 3 months advertisement or not, you will observe that p-value is 0.01. Again, which is less than 0.05. So I can say that there is autocorrelation between the third month, that means 3 lakh, and today's rate. There is an autocorrelation. Done? Any doubt till here? No doubt? Okay. I can explain this with the help of Excel also. What is the back end between these terms? How we are going to calculate it? Do you want to learn that too?
Madam.
Or you want to learn with the software only? Yes.
Madam, how to interpret that value, madam? That DW test 1.50. Here, DW test 10.918. What are the value?
This one 1.5047. For that, you have
yes.
to see the table.
Okay, madam.
So I can provide you everything over there also. But right now, let's go with the DW p-value, or what you can say that if you want to see DW, you will always observe that Darwin-Watson test lies between 0 to 4. So I can write it over here. This is Darwin-Watson test will lie between 0 to 4. Now, if the value should be 0 between 0 to 4, so 2 is your midpoint. So if your answer is 2, you can say that there is no autocorrelation if your value is 2. But if your value is between 0 to 2, so that means you can say that there is positive autocorrelation. And if the value is between 2 to 4, you can say that there is negative autocorrelation, but correlation is there. So if the value comes out to be 2 or near about 2, low autocorrelation is there, and we are okay with low autocorrelation. Either value is 2, 2.1 or 1.9, we are okay. But if value is 0 or 1 or 3 or between 3 or 4, we are not okay. So we will say there is autocorrelation, and you will observe over here your Darwin-Watson test value is 1.5. So either you can check with Darwin-Watson test value or you can check with your p-value. It's one and the same thing. Both the things will be giving you the same results.
Ma'am, if the value is 2.5 or 2.6, then it is okay or not?
It won't be okay. But in some cases, we can say it's okay depending on the model. So you can say that between, if it is between 1.5, 1.6 or 2.4, 2.5, you can say there is a low autocorrelation and we can go with the model. But if it is more than that, you should not go with the model.
Okay, ma'am.
And so now should I go with the Excel also or with the softwares only?
Madam, software
In
only.
the
Okay, madam.
software. Okay, fine. So next is your fifth. Fifth is your, there should not be any multicollinearity. Now multicollinearity means previously we have done that there should not be autocorrelation. Matlab error term should not be related. Now multicollinearity, what we are saying, independent terms should not be correlated. Got it? Now, if independent terms are not correlated, so the best way to find out is calculate the correlation among themselves. So what we are going to do, we are going to find the correlation among the dependent variables. So for that, your command will be for. Now over here, we are not having two independent variables. We are having three independent variables. So if more than two independent variables are there, so we are using the command data.frame. So data.frame, your first variable is your exports. Second is your imports. And third is your inflation rate. Now see over here, your results. Now you will see that imports and exports, their correlation is 0.998. That means they are highly correlated. So what does it shows that if I am going to take both the variables, exports also and import also, in my linear model, that means whatever model I am creating, whatever regression equation I am creating, if I am going to use exports as well as imports as an independent variables, my results will be biased. I will not be able to find out that which variable is explaining my independent variable, because they are highly correlated. So either take out exports from the model or take out import from the model. So that means now my first model will be FDI is equals to export and inflation rate. And second model will be FDI is equals to imports and inflation rate. And then I'm going to compare these two models, which is giving me the better results. And if I'll see with inflation and exports, your less correlation is there, 0.05. And if I'm saying inflation with imports, less correlation is there. So that means inflation rate is not correlated with either exports or imports. So we can include inflation rate with both the independent variable, one time with exports and another time with imports. Got it? And high correlation, you can say whenever your values are more than 7 or 7.5, then there will be high correlation. And if it is less, moderate, and if it is near about 0 point something, so we can say there is no auto correlation. There is no multicollinearity among the independent variables. So this is one of the way to check the multicollinearity. And another way to check is, that means I can say the first part is to check by correlation. And second part is to check by variance inflation factor, which is commonly known as VIF. Variance inflation factor. Now, if I am going to calculate with the help of these tests for variance inflation factor, I need to install the package. You have to install the package far away. So let me library the package. So I have libraried the package far away. Now I will calculate the VIF. So command is far away. Now see, if I'm writing far away, it's not taking far away because you will see the red button over here. R is still working. R has not opened the package far away. So that's why you will see the red button. Now red button is over. Now if I'll write far away, it will show me. See over here. Once the R has opened the book, it will automatically give me you the commands. So far away, and then I'll say VIF and my model. Now you can see over here, exports is 459, your imports is 460. That means they are highly correlated, isn't it? Now, how to judge whether they are highly correlated or not? Over here, I am seeing the values are good. That means they are in 459, 460. Isn't it? So that means if any value of VIF is greater than 5, there is a presence of multicollinearity. So for VIF, value should be less than 5. Your value should be less than 5. In both the cases, export and imports are values are more than 5. So multicollinearity is there. But in inflation, value is less than 5. So inflation rate is not correlated with any other independent variable. Got it? Now, next one, that means your sixth assumption says that residuals are assumed to be, or you can say are assumed to have homoscedasticity. So H0 says that data is homoscedasticity and H1 says your data is heteroscedasticity. Homo means you are similar. That means whatever the difference between the variables, how the variables are scattered will be equal, and hetero means somewhere distance will be less and somewhere distance will be more. You will have a fan-like shape over there. If you are getting the fan-like shape, so you are having heteroscedasticity. If you are not having a fan-like shape, it will be the homoscedasticity. Got it? Now, in this again, what I can do, you can make one of the package that name at broom. One of the packages broom. You can either install that package or even you can do by simple way. You can use the Brish-Pagan test. So first of all, let's do it with the test Brish-Pagan test. So first of all, we are doing with test and then we are going to make a diagram. So again, Brish-Pagan means BP test and your model. Now see over here. So P value is more than 0.05. So I can say that there is homoscedasticity. Got this thing?
In this, we will be using model
This we will be using.
or residual.
No, we will be using for the model.
Not for the
There are different packages for testing this. Even you can use the, there is one of the package car. You can even use the package car, and for that there are different commands. So this is the best way that we are using the Brish-Pagan test. Or even there is one more test, white test. And for that, there is a package. Let me check whether I have installed that package or not. There is a package named as Stardicity. So let me check whether, no, this is not the, no, I have not installed the package either. What you can do, you can just install the package. See, this is the test. This is a package to check your scardicity, whether there is a homoscardicity or your heteroscardicity. You can install this package. I'm not installing right now because it's asking me to update it. Let me see whether it's, yes, it's done. Okay, now it's done. So let's library the package. SKE. Done. So now you can just write white underscore LM and your model. I think some problem is there. Let me check. No, there is some problem. I'll just check it because right now over here also we are getting the p-value which is 0.881 again, which is more than 5% level of significance. So this test is also saying that there is a homoscardicity. So both the tests are saying that there is a homoscardicity. There are various packages. There is one more test which is known as constant error variance test. You can use that test also. But do remember, whatever test you are using, please give the literature review also with that. That in which research paper you have seen this kind of test. You have to give the backup of each test you are using. So whenever you are writing a research paper, always give the backup of the previous researchers, which test the previous researchers have used, as well as your theory. Your theory is the base for doing any test over there or applying any model in that. So don't apply the test only blindly. There should be some hidden theory behind that. Now, any doubt till here? Yes, any doubt?
No, madam. No, madam.
Okay, let's move to stata fast. Now all the assumptions are clear. I can do it very quickly about the stata. Now stata, same commands are there. You have observed in R also, all the abbreviations we are using. R has not developed any command where more than, you can say just the first letter of your test is used. So no difficulty will be there in your R as well as in stata. Same commands will be there. So just have me import the file. Okay, now in this file, I have imported the another file over here. I have taken USD INR. Instead of inflation, in this file, USD INR is there. So it's one and the same thing. You can use with the inflation. Now, what should be my next command? Now I have to give instruction to the stator that this is my time series data. So TS set and your date. Now, first of all, we have to create a model. In R, we have created the model and we have used the LM test. Now the command over here is regress. After writing regress, you will first of all write your dependent variable, which is my FDI. And after that, I'll write my independent variables. Exports, imports, USD, INR. Now you can see the results over here. Got the results? Now, first of all, the first assumption that we are going to do it, whether my residuals are normally distributed or not. So if you remember in R, what command we have used? We have used the QQ plot. If we see my R and first is normally distributed. See over here. The residuals are normally distributed. I have used QQ plot, Shapiro-Wilk test, and Comgrove-Simroff test and Jarque-Bera test. Same test we will be using in Stata also. So first of all, QQ test. So for that, our command will be, first of all, now we have to create residuals. If you remember in R also, we have created the residuals. So we will also create the residuals over here. So to create the residuals, what we are going to write over here, I am saying predict. We are giving instructions to Stata that predict my residuals, and the name for the residuals I am giving resid, comma, RE. Now, just understand this command. I am giving instructions to Stata predict the residuals. RE means residuals, and the abbreviation that I have given to residuals is resid. Now you will observe over here my residuals. The label is residuals and variable name is resid is created. And if you will see over here, I can show you the variables. See, this is date, your FDI, exports, imports, USD INR I have given. It has created the residuals over here. These are your remaining part. These are their residuals. Now, all the assumptions will be with respect to my residuals. So first assumption is that residuals are normally distributed. So we will be using Q norm. Q norm, and then the abbreviation that I have used for residuals is resid. Now see the diagram. All the variables, all your residuals are not falling on a straight line. If it is not falling on a straight line, that means my residuals are not normally distributed. This is one of the methods. Second, instead of Q norm, we can use P norm also, and then resid. Now again, you can see that your residuals are not normally distributed. They are not falling on your straight line. All these residuals should be there on the straight line. Now, if the number of observation is less than 50, use Shapiro-Wilk test, and command is Shapiro. For Shapiro, we are using S, and Wilk for resid. Now, your probability is 0.000, which is less than 5%. So I can say that my data is not normally distributed. Your diagram is also saying the same thing. Your probability of Shapiro-Wilk is also saying the same thing. Or now we can use Jarque-Bera test also. So JB and Jarque-Bera short form is JB, and then residual abbreviation is Brexit, and enter. Now again you can see that probability is 0.00. That means your residuals are not normally distributed. It's always given over here. H0 is normally distributed, H1 is not normally distributed. Got it? Any doubt till here?
No, madam. No, madam.
Okay, next will be that we will be checking the whether your residuals are having homoscardicity or heteroscardicity. So we are using, we have used the white test. I recently used the white test. You will see over here. This was a white test that we have used, white model, white test. So similarly, we will be using white test in Stata also. So your command will be estat IM test. Now you can see if p-value is less than 0.05, we will go with alternative hypothesis. If your p-value is more than 0.05, we will go with null hypothesis. And over here, value is 0.05, so we will go with alternative hypothesis. And you can observe over here, my alternative hypothesis for homoscardicity is alternative say that there is a heteroscardicity. H0 says there is a homoscardicity and here p-value is less than 0.05. So please mute yourself. So since the value is less than 0.05, so I can say that there is heteroscardicity. And you will see over here also it's written that it is heteroscardicity. Got it? And even we can check it by Brush-Pagan test also. So for that, your command will be estat and HE test. Estat. No, I think some command problem is there. Yes, HET test. Now again, you can see that your p-value is less than 0.05, so heteroscardicity is there. I'm going to give you all these commands. Now next is that there should not be multicollinearity. And for multicollinearity, we have learned there are two tests, either by calculating correlation or by calculating VIF. So if I'm going to calculate with correlation, so core, exports and imports, I'll do one by one. So you can see that exports and imports are highly correlated, 0.933. Now let's check for others also. Core, exports, and your USD INR. Now see over here in the R when we were doing, I have imported with the inflation. Here USD INR is also highly correlated. That means all these three variables are highly correlated among themselves. So we have to take either one, either drop exports, drop imports, or drop USD INR. I cannot take all the three variables in one way, in one shot. And another way is by calculating VIF. Now you can see over here what we have learned that the value should be less than 5. Over here, exports and imports are having more than 5. So they are highly correlated, but USD is also near about 5, 4.09. So I can say that this is also highly correlated. So what I'll do, I'll take USD INR only. I will not take exports and imports. maximum what I can do, I can take export and USD INR or imports and USD INR. But I cannot take exports and imports simultaneously. Now, your mean should be 0.
Ma'am,
So just, yes, sir.
ma'am, could you please repeat the VIF command again? VIF
Only
command.
VIF, only VIF, just write VIF only.
Oh.
Nothing else. Just write VIF, you will get the results. And opposite 1 upon VIF is tolerance power. Now, either you can use this, we have learned by correlation also, we have learned by VIF also. Now, next is mean of the residual should be 0. So let's calculate mean and resid. Now see over here, mean is 1.83.06. So mean is coming to be 0. So let's plot it. There, there is different command. I think line command I have to give it to you. Otherwise, it won't get the line. Otherwise, you can see that residuals are near about 0. It's again giving me the terms in exponential terms. So it's near about 0. So I can say that this assumption is fulfilled. Now, next assumption is that there should not be no autocorrelation. In no autocorrelation, we have learned that there are two different tests. One is Durbin-Watson test when the lag value is 1. So for that, what we have to do, first of all, we have to regress again. Otherwise, it won't run. Regress your FDI, exports, imports, and USD INR. And now write DW stat. Now you can see that DW stat, the value is 4 over here. So that means it's showing that there is autocorrelation. Because we have learned that if value is 2 or near about 2, there is no autocorrelation. And if it is more than 2, there is autocorrelation. Now, any doubt till here?
No, madam.
No doubt? No one is having any doubt?
No, ma'am, no.
So what I can expect that till tomorrow you will be able to learn all your assumptions, because my next topic, your ARIMA model, will be based on your assumptions only. So you should practice all these assumptions so that we can go with the ARIMA model. Okay, let me stop the recording.